Welcome to this video. My name is Roel Dobbe, and in this video we will explore how important public values such as fairness, inclusion, and accountability are connected with the technical systems that manage our energy grids. In this video, we will make these complexities more tangible in an engineering and policy context. The aim is twofold. First, understand energy justice as a socio-technical system property, and second, examine how policy goals for energy justice can be translated into engineering and governance practice. In the previous video, we saw how energy justice concerns may emerge in novel control systems designed to address congestion issues in electricity grids. Design of such control systems should be in line with the existing laws and policies for the energy system. But as we saw in the second video, energy justice is still a relatively nascent topic. So it may well be that there are no good principles and policies yet, while at the same time energy injustices start to emerge. Insight from practice may well and does often inform the development of missing laws and policies. Therefore, what is required in the energy transition is a stronger dialogue between engineering and design of these control and operational systems, and the associated processes for law and policy development, including the role of democratic debate and decision-making in local, regional, national, and sometimes international parliaments. Energy justice has strong similarities with another value that has been central to engineering for much longer: safety. Safety is highly normative. Even when experts agree on many technical requirements, safety procedures will still vary across sectors, countries, and cultures. Safety cannot be attributed to the technical system alone. A plane built to safety standards is not necessarily safe to fly. Safety also depends on training, maintenance, infrastructure, and organizational culture that encourages raising and addressing potential safety concerns early on. Put differently, safety emerges from the interactions between technical, social, and institutional aspects of a particular sector and the context in which technologies are used. In short, safety is a socio-technical system property. Now, the same perspective helps us understand energy justice. This socio-technical view requires considering different processes that together form the control and governance structure through which energy justice aims are interpreted and operationalized in engineering and met in practice. In the primary operational process, we want control logics that distribute benefits and burdens in ways that are acceptable and legitimate. We also need operators to monitor patterns in who benefits and who carries burdens, and to steer or adjust control choices to prevent distributions from becoming unacceptable. Secondary processes are those that are not directly operational in the network, but that are required to ensure proper operations. These include the management and instruction of personnel, as well as the regular maintenance of the electrical grid, including developing or updating the control systems with changes in the network or with new technologies. Tertiary processes include roles that translate laws and policies into engineering requirements and work practices, as well as accountability and oversight functions. Within a utility, this may include policy officers, general management, and internal supervisory or compliance functions that oversee whether laws and policies are met. Beyond the company itself, tertiary processes also shape how energy justice policies and norms are developed and enforced. This includes democratic institutions such as parliaments, executive branches such as ministries, and other actors such as citizen collectives, advocacy groups, industrial associations, and lobbying firms. External supervisory organizations may oversee whether utilities implement policies and meet associated norms and standards in practice. And they can also flag new energy justice issues emerging in the grid and ask the Parliament to have a debate about whether a policy response is required. Taken together, this provides a more integral view of how energy justice challenges show up in engineering practice and how they connect to a wider landscape of actors, processes, and responsibilities. In safety engineering, this broader set of practices, processes, norms, standards, and responsible actors is often described as a control structure or a safety management system, a system of systems. For energy justice, we are still at the beginning of understanding and addressing growing concerns. Many of the necessary norms and associated practices may not yet exist, or may still be under development. But that does not make the socio-technical view less relevant. On the contrary, we can be certain that energy justice effects are the result of both choices and assumptions made across engineering, policy, and management. Without a more integral lens, we will surely miss or not be able to anticipate how choices play out in terms of the impact on different groups and citizens. Analyzing operational systems together with the surrounding processes and actors helps us see how distributive, procedural, recognition, and restorative concerns can emerge in practice and where interventions lie in the control systems, the organizational processes, or the broader governance mechanisms that may be needed. Let's summarize what we covered in this video. We connected energy justice aims in policy to engineering and governance practices. Using the analogy with safety, we argued that energy justice can be understood as a socio-technical system property, emerging from interactions between technical systems, work practices, organizations, and institutions. Finally, we introduced the idea of an energy justice management system to highlight the operational, organizational, and governance processes that shape how energy justice norms are set, implemented, monitored, and upheld.